Hello, my name's Thanom and I'm from UNSW. Today I'm working through some of the Math 1011 calculus questions from the section on integration by substitution. So the first question is asking us to find the indefinite integral of 2t multiplied by 3t squared minus 5, all to the power of 4. So we need to realise that here we've got a function of a function. We've got 3t squared minus 5 inside, but all of that is to the power of 4. Now if we want to integrate something to the power of 4, we'd increase the power by 1, divide by that power. If there's an extra function in here, we really need to reverse some sort of chain rule. So the key is that the inside differentiated is 6t, which is almost here, so we are going to be able to use some sort of reverse chain rule. Okay, so let's think about this. Perhaps, right, if I add something to the 4, perhaps the answer, the antiderivative, would be 1/5 3t squared minus 5 all to the 5, right? If we just thought about this outside function here, something to the 4, it would anti-differentiate to this. If I wanted to check that, I would differentiate it. So this differentiates to the 1/5 would stay there. When I bring down the power and reduce the power by 1, 1/5 times 5 is 1. So I end up with 3t squared minus 5 to the 4. But the chain rule says in addition to all of that, I need to multiply by the derivative of that inside function, which is 6t. So the key is that if this differentiates to this, then 3t squared minus 5 to the 4 multiplied by 6t anti-differentiates to this. So the derivative here is sitting here. So I don't have 6t multiplied by that, I have 2t multiplied by that. That's okay. I can just multiply by 3 here and divide by 3, so I don't change the question, and I'll be able to solve this question. So here, I'm going to multiply this by 3, and I might even write it on the end here, like this. So I multiply this by 3, but I can't change the question, so I'm going to multiply by 1/3 as well. So 2t is indeed 1/3 times 6t. Now I can anti-differentiate this because I know this expression anti-differentiates to this here. The inside differentiated is sitting here, so I can reverse this chain rule. So we get 1/3, the integral, sorry, not the integral, we're already finding the integral. So I get 1/3 times 1/5 3t squared minus 5 all to the 5 plus c. So this is my answer here. Now, this is what we would call integrating by inspection. We're checking that the derivative of the inside here is sitting there. So we've got a 6t there, and then once I have that f dash, I can reverse the chain rule and I can integrate something to the 4 as 1/5 something to the 5 there. We can more formally do that using integration by substitution, right? So it's the same idea, but it just we use a substitution to make the integral look simpler. So alternatively, using the substitution, u equals 3t squared minus 5. So we let u be this function on the inside of this power here. So if we use this substitution, then du dt is going to be 6t, or du is going to be 6t dt. So I need to replace a 6t dt with a du. So our first step is going to be the same, right? Our first step is going to be, let's write the whole thing out, that the integral of 2t 3t squared minus 5 to the 4 dt, right? I need a 6t dt to replace it with a du, so I still need to multiply it by 3 and 1/3 to make this work. Okay, so we multiply by 3 to get 6t dt, multiply by a third so we don't change the question, and this is 3t squared minus 5 to the 4. So this step is the same as this step, but now by doing this substitution, u equals 3t squared minus 5, this integral now looks like u to the 4 and the 6t dt is a du. So I can see this is really just an integral of u to the 4 du. So this is 1/3 times 1/5 u to the 5 plus a c. And at the very end, we'll just substitute back 3t squared minus 5 for u. So this is 1/3 times 1/5, 3t squared minus 5 to the 5 plus a c. So you can see that the process is essentially the same, but with the substitution, we're more formally going from this step to this step by letting u be 3t squared minus 5 and noticing that all of this is just du. And to integrate a power of 4, we just have 1/5 times that to the power of 5. So this is just more formally doing it with a substitution, but it's the same idea. Question 1f is asking us to find the indefinite integral of x cubed over the square root of 1 minus 4x to the 8 here. And they've given us a substitution, u equals 2x to the 4. Let's use the substitution and then we'll look at our solution and see how we might have seen to do this question by inspection. So if we let u equal 2x to the 4, we need to substitute everything. So let's work out du dx. That's going to be 8x cubed. So we need an 8x cubed dx to substitute for a du. So I have an x cubed dx. I just need an 8x cubed dx to substitute it. Now, u is 2x to the 4, and we need to recognize that 4x to the 8 is really 2x to the 4 all squared. So let's rewrite this integral here. We have 1 over the square root of 1 minus a 2x to the 4 all squared. And then we have an x cubed dx, but I really need an 8x cubed dx to substitute it. So I multiply it by 8 and multiply by 1/8 so I don't change the question there. So now I'm ready to do my substitution. I have 1/8. I have the integral of 1 over the square root of 1 minus u squared here, because u is 2x to the 4, and 8x cubed dx is a du. So this integral is simplified to 1 on 8, the integral of 1 on the square root of 1 minus u squared du. And I know how to integrate that. That's inverse sine, where a is just 1 here. So this is just going to integrate to inverse sine. We know inverse sine of u differentiates to this, so that must anti-differentiate to inverse sine of u plus a c. Now, u was 2x to the 4, so this is 1/8 inverse sine of 2x to the 4 here, plus a c. So we were given a substitution and we could use that substitution to find the integral. Now we could have done that by inspection. Doing it by inspection would have involved recognizing the square root of 1 minus 2x to the 4 all squared here, and recognizing that the inside of this 2x to the 4 differentiates to 8x cubed, which is almost here. Right? So if you recognize that this differentiates to 8x cubed and adjust things, then you know that we're reversing a chain rule here. The inside differentiated sitting there, so we just need to find an antiderivative of 1 on the square root of 1 minus something squared, which we know is inverse sine of that something. So by inspection, you would have gone from this line here to this line here, but more formally by substitution, you would have let u equal 2x to the 4, simplified the integral in terms of u, and then you would have got to the same result at the end of the day. In question 1f, we're asked to find the indefinite integral of x times 2 minus x all to the half, and we're given a substitution that we can use, 2 minus x u equals u squared. So this is one where the substitution isn't equivalent to integrating by inspection. We don't have an f dash of x times another function of f of x here. So we are going to use the substitution to simplify this integral and work out the antiderivative. So 2 minus x equals u squared is a sensible substitution because if I have u squared to the half, I will no longer have these fractional powers or these surds. So let's do the substitution. First of all, I'm going to make x the subject here. So x is 2 minus u squared. So I know that this x is going to substitute for 2 minus u squared, and the 2 minus x here is substituted for a u squared. I need to substitute the dx as well. So dx du, 2 differentiates to 0, minus u squared differentiates to minus u. So the dx we're going to substitute for a minus 2u du. Okay, so let's rewrite this integral now in terms of u. X is 2 minus u squared. 2 minus x is u squared. And dx is minus 2u du. So this is just a u here. So I have minus 2u squared multiplied by this. So that's minus 4u squared plus 2u to the 4 du. So once I expand and simplify this, I'm going to get this expression here. I can integrate this because these are just powers of u. So minus 4 over 3 u cubed plus 2 over 5 u to the 5 plus c. And at the end of the day, we need to substitute back substitute back u, which I don't have exactly. So u squared is 2 minus x, so u I'll write as 2 minus x to the half here. So I'm going to substitute back 2 minus x to the half for u. So we'll get minus 4 thirds, 2 minus x to the half to the 3 is to the 3 on 2, plus 2 fifths, 2 minus x to the half to the 5 is to the 5 on 2, and then plus a c there. Okay, so we're using this substitution given to us, and that substitution wasn't equivalent to an integration by inspection in this particular question.